My name's Jonathan. I'm a principal engineer at VMware. I work primarily in the desktop group, and today I'm going to go over ThinApp specifically and what's been changing in the ThinApp product. As in the second half of the session, we'll go over some of the future vision and some of the things that are cooking in the lab, so that'll be really fun to see. Before I get started, I just want a quick show of hands to see who all here is familiar with ThinApp. Raise your hand if you are. Just seeing if I see, there's a couple of hands that didn't go up. So I'll give you the 30-second overview so the rest of the talk makes sense. ThinApp lets you take Windows-based desktop applications and convert them into a simpler format that can be delivered as either a single exe file or a small set of exe files. And it simulates a registry and a file system for the application so that the application believes that it's installed on the system that you're running it. And this simplifies the rollout, update, and deployment process for applications. As well, it can be used to prevent conflicts between the application and the desktop or other applications. All right, that being said, now we'll jump into first half is more nitty-gritty details. What are the technology changes? The standard disclaimer. Some of the things I'll be talking about have not been released, so VMware is not making a commitment to release those, but we sure hope they come out. Since VMworld 2009, we've had 3 releases, and you can see here we're doing a release cycle approximately every 4.5 months, about once a quarter here. I'm going to go over each one of these releases, what are some of the new things that came out in those releases. So starting with 404, this is mainly a maintenance release. And one of the big things that we targeted in terms of features is to make this a robust, reliable solution by adding journaling to the registry and virtual file system metadata. And for those of you who work with databases, probably know about journaling. It's the ability to write disk commits in a journal file such that if you get a power outage or a network failure, you can recommit those writes that are backing more complex disk writes. So this helps to prevent the registry and the file system from getting corrupted in the case of a power outage or network failures. And network failures are probably fairly common in people's environments. Another use case where people often run ThinApps is from a USB key where you may eject the USB key and all the disk writes haven't been committed. So this is a nice feature. It doesn't necessarily mean you won't lose any data. What it means is that you won't corrupt the registry and the file system next time you launch the application. And that was an issue that you would run into maybe once in 1,000 users, but if you start deploying to large numbers of users, you've got 10,000 desktops, 1 in 1,000 starts becoming pretty significant to you. All right, and ThinApp 4.5, we got our full Windows 7 support. 4.04 actually had mostly supported Windows 7, but in 4.5 we got a chance to do a full QA cycle against Windows 7. And because the Server 2008 R2 kernel is built on Windows 7, we're also supporting that, so x86 and x64 platforms. Some of the other big enhancements for ThinApp 4.5 are performance improvements. So we looked at how we can load applications faster, how we can reduce the amount of memory they take, how we can stream them from a network share with less bandwidth consumed. And we made really big improvements in all those areas. I'm going to show you a couple of benchmarks in a second here. Some of the other less important, but important to some people, we support, I think for the first time, MSI files larger than 2 gigabytes. MSI is one of these file formats that everybody uses, but it was built a long time ago before Microsoft thought people would have files larger than 2 gigabytes. And we've done some really clever things to allow you to have any size MSI file that you want, one single file, which is nice for deploying through a URL. If you want to give a user a web address to go and get an application, you're just pointing them to one file. They download that. They've got everything they need for that package. We sped up the MSI installation by twice and reduce the number of disk writes that it does significantly. We were kind of surprised to learn that when you install an MSI, typically it will make 3 copies of the file data, the MSI exec service, before it actually puts it in the right place on the machine. One other area in 4.5 was the ability to capture on non-clean machines. And this is specifically meant to address the use case. Almost everybody does their capture in a workstation or ESX type of environment because you want to use VMs to get that clean environment and also revert it back to a clean state after you've done your capture. But in those environments, everyone is going to have VMware Tools installed on those environments. And VMware Tools actually comes along with C runtime libraries that get pushed on the machine. So now you're looking at an environment that's no longer clean and you're capturing the diff of what changed inside that VM. If the C runtime's already there, then you got an issue. If the application also uses the same version of the C runtime, it won't get captured. And if you go deploy that to a machine that doesn't have that C runtime library, then it's not going to install. So we did some nice things there. When we install an MSI application, we can actually look at its database and determine dependencies that it might have that are already installed on the machine. We can look at the machine's install configuration. And from that, we can now say, if you want to install VMware Tools when you capture, go ahead, it'll work. We haven't gone out and done extensive testing to push where the limits are on this. Like if you captured, say, a machine that had Office and 10 other applications, there may be some edge cases that don't work. So our recommended use of ThinApp is still to capture on a clean machine, but VMware Tools is nothing to worry about. Another area that we made some changes in ThinApp is how we support people who do whitelisting. And those of you who are concerned about security in your environments, there's different ways that you can try to prevent the user from bringing malware into your environment. And a lot of people will try to block executables at the launch level. So you can specify a list of EXEs that are allowed to run in your environment, and that's called a whitelist. Anything that's outside of that whitelist gets blocked by the operating system. Windows 7 has something built in called App Blocker, and there's a number of vendors that also support that for older platforms. But one of the issues with this is that you need to determine ahead of time what that whitelist is. What are the EXEs that you're going to run? And with a ThinApp package in the past, if you had a child process inside of a virtualized application, we would dynamically generate a small stub EXE in the user's profile when you launch that application. And that made it harder to determine ahead of time what are those whitelisted applications I need to put in my list so that this application works correctly. So in ThinApp 4.5, now, as far as Windows is concerned, you're launching the same application multiple times, even if you're launching a child process inside that application. Example, if you go and you use ThinApp 4.5 to capture and deploy Office, when you launch Outlook and Outlook opens up an email, it's going to launch Word to do the editing. So in Task Manager, you would then see Outlook and Word in a normal environment. Under ThinApp, you're going to see 2 copies of Outlook in Task Manager. This means that you only have to whitelist the outer package and say, this is what the user is allowed to run. Anything inside the package is automatically going to be included in your whitelist as far as Windows is concerned. This change has caused some complications for some people who have external tools that go and look at things in Task Manager and they want to know specifically what things are. So we have some tips on our blog on how you can get the real virtualized process name for people doing this. All right, so on to the memory sharing performance improvements. So the way that Windows launches applications and loads EXEs and DLLs is it starts out by mapping an EXE into memory from disk. It doesn't actually load all the contents into memory. And If the application writes to code pages that have been mapped into memory, Windows does a copy on write and has a unique copy for that individual process. In older versions of ThinApp, we would load the exe contents from the package directly into memory and allocate that entire amount of memory locally. So this caused a higher amount of disk commits and a higher, less code sharing. And this becomes important for people who are deploying either in VDI and terminal server environments. In VDI, people are concerned about the number of IOPS that they're generating. So if you have more swap file activity, then that's going to be a factor in terms of how well you can scale or perform on your desktops. If you're looking at terminal server environments, you want to be able to share those executable code pages not only across single processes, but across multiple users on the same system. So ThinApp 4.5, it lets us do code sharing across a suite of applications and across multiple user logins. And in the multiple user login case, with terminal server, if 2 users launch Word, there are only going to be 1 copy of Word's code pages in memory. In the suite of application case, you might have Word and Outlook, and they actually share a few common DLLs that they both load into memory. And now there will only be 1 copy of those DLLs loaded into memory with ThinApp 4.5. All right, so let's go on to, one last point to mention. When does the code sharing occur? Well, it occurs if the package is run by multiple users from the same location. So in a terminal server environment, you want to put your packages in a global read-only location and have all the users launch the application from there. That will ensure that the code pages are shared. If they're not in the same location, then each user would have their own unique copies. Once in a while, people have asked, are there any security implications with that? Can one user somehow attack another user? And assuming that the location where those packages are stored is read-only, then all the memory changes are copy on write and unique to each user. In fact, unique to each process. So there's no security risk involved in doing that. All right, here's showing some of the performance improvements in ThinApp 4.5. One of the big issues that users have, or one of the things that's important to them, is how fast does it take to launch the application. If they're doing this all day long, over and over, they don't want to wait an extra second to longer than they have to. So in 4.5, you can see here the first launch of an application on a cold disk cache, which is probably the most common case where a user logs into a desktop. They haven't run it before. First thing in the morning, they launch it and they leave it open all day. We've gotten the startup time down from 7 seconds to less than 4 seconds. As well, you can see the bandwidth consumed for streaming PowerPoint 2007 from a network share has gone down approximately 50% from 404. So to put this in perspective, this is 160 megabytes in 404 out of maybe a 2 gigabyte Office package. So that's how much bandwidth you're going to have to pull over the network to get PowerPoint up and loaded on the local PC. Any bandwidth transfers after that are usually just trickles of little bandwidth if new DLLs or code pages are running. So the biggest hit that you're going to see is on application launch. And we've now gotten that down to about 80 megabytes in bandwidth transfer. Okay, on to ThinApp 4.6. So ThinApp 4.6 just came out 2 weeks ago. So after the conference, go download the bits. I'm going to show you some cool things that you guys can do in your environments. One of the big focuses of ThinApp 4.6 was to support the IE6 use case on Windows 7. We heard from a lot of our customers that are trying to migrate to Windows 7 that the single biggest blocker is IE6. And since Windows 7 comes with IE8, there's really no option to downgrade to IE6. And Some people have looked at using terminal servers and publishing an IE6 browser into the desktop, or using a full VM to run an IE6 instance. But this is really a very lightweight, easy to deploy, small footprint method. The amount of memory consumed for a virtualized IE6 process is, I don't know, somewhere in the range of 30 megabytes. The amount of disk space for a virtualized IE6, somewhere in that range as well, 30 megabytes disk space. And ThinApp, because it can run as a single file, it has no pre-install requirements. You don't need any device drivers, clients. You can just push this as a file to your desktops, and the user has IE6. It doesn't need elevated security privileges. You can run it directly from a lockdown user account. So what's interesting about IE6 is how long it was around in the corporate environment. It still is around. Over the last 10 years, lots of people have created web pages, plugins, ActiveX controls that all are tied to IE6. So when people bring up the IE6 question, it's usually not just IE6, but also a lot of plugins that go along with it. So one of the things that we did to make IE6 work better, besides the core virtualization of IE6 and just making that work on Windows 7, is to make it easier to create IE6 packages. In the past, because of the way you capture a ThinApp package, you'll start with a machine that doesn't have the app. You'll install the app and capture the changes. Well, with IE6, that meant you had to go to Windows 2000 and start out with IE5 and do an upgrade process and capture the changes for that. And that gets a little complicated if you want to capture IE6 and maybe some set of plugins that go along with IE6, because maybe those plugins only work on Windows XP. So you've captured on 2000, and then you have to continue the capture on XP or do AppLink or things like that. So we made it really simple. It's 2 clicks in ThinApp 4.6. Look for this button on the setup capture. You start with a clean instance of Windows XP. And if you have XP and you haven't upgraded to IE8 yet, then we can we can create an IE6 package using the XP image. You don't have to do any install at all. You click on this button, and a second dialog comes up, and it gives you 3 options. One option is to include an entry point for a fully virtualized IE browser. And at the end of the capture process, what we'll do is we'll suck in all the files from the Windows XP instance and give you a ThinApp project, which can be built into your virtual IE6 exe. While we are sucking in the files from the Windows XP instance, I wanted to point out that we're using the files that are shipped with the IE6 SP1 redistributable from Microsoft on their website. With one exception, we do need to use the Shell32 DLL from XP on Windows 7 to make IE6 work. One thing that people bring up about IE6 is, okay, well, it works great. What about the support question? Who do I call if I have an issue? Because Microsoft isn't going to support IE6 on Windows 7. And there is no issue here. If the issue is reproducible on Windows XP with IE, then you can call Microsoft for support. If it's not, then you can call VMware for support, and we'll officially stand behind this and support IE6 on Windows 7. I think it's one of the few times where we are standing up and saying we'll support an application on a platform where it natively just will not work at all on. To also make this even more palatable for people, we have a new feature called ThinDirect, which allows you to keep your native IE instance for the majority of your use cases and switch to a virtualized IE6 for the cases that you need those virtualized browser applications. I'll show you that in a second here. So ThinDirect is a new feature in 4.6 that essentially it's a browser helper object that gets installed into the native instance of IE. And its job is to sit there and watch and monitor the URLs that the user is visiting. If the user visits a URL in your whitelist, then they will be redirected to the browser of your choice. IE6 is probably the more typical one. If the user then navigates away from that URL using the virtual IE6 browser, then they'll go back to the native IE browser. So this is what an end user would see in the browser. They see a little message saying they've been navigated away, and another browser will pop up. I'm going to show you just a quick little demo so you can see it in action here. So the user clicks on a link or navigates to a URL that's in your whitelist, and the virtual IE6 browser pops up. In this case, I went to a page that shows me what version of IE I'm using. And then I navigate away, and I'm switched back to the IE8 or IE9 instance. All right, pretty simple. So let's talk about some of the use cases for using this. The most obvious one is if you have apps that don't work and require IE6 and you want to redirect from IE8, you can use ThinDirect to do that. As other browsers are taking steam in the industry, there's also starting to become web pages that are not compatible with any version of IE. HTML5, for example, is a new standard that IE doesn't support yet. So if you have web pages that are using HTML5, you may want to redirect users to a beta version of IE9 or maybe Firefox or Chrome. A very common use case in lots of environments is people have web apps that need old versions of the Java runtime. And this allows you to redirect those URLs to a version of a browser that has that specific version of Java runtime. And the nice thing here is we've eliminated the need to do any user training. This is all automatic from a user perspective. They just go somewhere, they see another browser pop up, and they're like, okay, I'll keep on working. You may want to use this feature to simplify your desktop deployment strategy. Right now, you kind of have to bake everything that a user needs into your image if they need various ActiveX controls, WebEx, etc. This allows you to start pulling back some of the pieces and saying, well, I don't really want that installed on the desktop. I'll have the user redirected to a virtualized browser if they go to XYZ web page and they can use that specific plugin. ThinApp, because it has the ability to do things like disable cut and paste for the process or printing capabilities, if you wanted to have the user have lower rights for certain web pages, maybe very sensitive web pages, you could redirect them to a browser instance that has cut and paste and printing disabled. All right, so I think that is everyone could probably find some use case in their environment for one of those. Let's talk about how you would actually deploy this in your environment. So the ThinDirect settings are stored on the machine in three different places. You've got settings that you can put in the registry per machine, per user. And those will get deployed using an ADM file. If you want to use Active Directory, you can push out all the settings to all your desktops using group policy. And that's probably how most of the larger customers will use this. You just set it in AD and forget about it. As well, if you want to update any settings later on, it's very easy to do. You can embed this information in ThinApp packages. So, for example, if I package up Chrome as a browser, now Setup Capture has a screen here where I can enter in any URLs I want to redirect to this new browser. And when I deploy that to my desktops, that package will install the browser helper object on that machine if it's not already present, and put the settings on the desktop for these URLs, in addition to anything that's already out there. I can also put those settings in my package.ini file after I've captured the package. Actually, there's a new file called thindirect.ini that you'll find in the root directory of your application. And finally, one last method. All the settings are just files, either in a per machine or per user directory. And so you can drop in new files in that location, and that will update the settings. Or you can modify those files directly. They're just text files. So lots of flexibility in how you can deploy those settings. Okay, moving on. ThinApp 4.6 also introduces the ability to virtualize services that you want to run at boot time. And ThinApp has always had support for virtualizing services that are application specific. So a use case in the past, a lot of times people would have an application that maybe needed a database to store its settings. And so that application would install a database along with its normal install. And ThinApp in the past virtualized services and continue to have this model supported. When that application started up, we would start a virtualized service on a per user basis. That database would have all of its database files redirected to the sandbox, and it would be unique to that user. So in ThinApp 4.6, what we're doing is we're allowing you to have services be registered at boot time. So you use the same utility you used before, thinreg.exe, or pushing an MSI to machine. And just like before, you have a single exe file which represents a potentially very complex service. You can do, SQL Server, MySQL, Apache, things like that. When that gets put on the machine as a single file, at boot time, Windows will look at the registry and it'll see a key that thinreg has written in and know to launch this as a service. So with this, you'll actually see the virtualized service in the Service Control Manager. So a few use cases for that. Why would you want to do it? The same reasons you'd want to do desktop applications. Simplify your deployment of these services. In some cases, services can be really huge. We have a customer who has a 6 gigabyte server-based application, and being able to deploy it as a single file has a tremendous value for them. Services also, just like any other application, they often depend on a lot of libraries, runtimes, and components, and being able to package them up as a single file allows you to put multiple services on a machine with less concern about conflicts between those components. And a use case that I think may be interesting, though we haven't proven it out yet, is the ability to do a fast scale out of server-based applications where you have a pool of pre-booted VMs and you don't necessarily know what service you want on those VMs yet, but based on the load and as things progress, you can have a ThinApp service started up within seconds versus having to wait for the whole machine to boot up. So these are things that this is brand new stuff, so we're looking to see how people use it, and we'd love to hear from you guys if you find specific use cases that you find compelling. Okay, so now I'm going to talk about a new feature, which I think is a first step in a big direction future for VMware and ThinApp. And this is something we're calling a ThinApp Converter. And ThinApp Converter, essentially, we want to automate the conversion of other various types of packages, maybe an MSI package, maybe a .exe bootstrapper, maybe some homegrown type of deployment system, and convert them in an automated fashion to ThinApp packages. Now, this is something that people have tried in the past, and one of the things that you might naturally think about is, well, an MSI is just a database file. why don't I just look at that database and grab all the files and registry keys and create a package from that? Well, that doesn't work very well because a lot of MSIs have custom actions that are code that gets run when the application installer executes. So if you don't know what that's going to do, you can't create a package from that. So it turns out the best way to figure out what's in the package is to run the installer. And VMware has a lot of great technologies for allowing you to run applications installers in the sandbox clean environment and look at the results. So this is what ThinApp Converter does. It automates the process of acquiring VMs, doing snapshots, copying the packages into the VM, running the application with silent install parameters, and capturing a ThinApp package and copying the contents out of that VM, and then reverting the VM back to a clean state. Now, if you have a lot of applications, you may want to do that over and over and over. So we can do that in scale if you like. If you have a pool of VMs, we can dispatch a workload to a bunch of VMs at the same time and speed up that process. But the nice thing about this is that if you can automate things that you do often, you can save a lot of time. Nobody's ever going to automate everything that they do. The key is to focus on automating things that you do over and over that are going to give you the most bang for your buck. So on the back end for the VMs that are supported for ThinApp Converter, these are the platforms that you can use. So you can use any one of these to do the capture and conversion process. And somebody was telling me that they tried it on Fusion and it worked. So that sounds interesting as well. Let me show you a quick demo of what that looks like. All right, so before I start, because this is automated, there isn't a whole lot to see. But what you'll see at the end is we're going to take 3 applications, dispatch them to 3 VMs, and come up with 3 ThinApp packages. And there isn't a lot of UI on top of this. I'm going to show you some future stuff where there's some pretty sexy ways that we can utilize this technology to do more. So you start with a configuration file, and that'll tell a converter, where your VMs are, where your packages are, where you want to put the input and outputs of the conversion process, and just run it as a command line here. And it'll go off and it'll check to make sure, it needs to be able to log into the VMs, and it needs to make sure that it has right access to the network share where you're putting the output, things like that. You let it run, and it may take a while, but since it's automated, you don't really care how long it takes. At the end of the process, here's the output. We look in WinRAR directory. We have both the ThinApp project and the built exe. We can just launch that, and we've got a virtualized package. So pretty nice. Okay, so now, where can we go with that? One of the things in the keynote this morning was, how do you get end users the apps that they want, not necessarily just the apps that they need. If an end user comes to you and they say, I need Skype or I need this IM client, either you're going to give them admin rights and say, go do it yourself, or you're going to say, well, give me a business justification so I can spend my time doing that for you. And even if you could get just business justification to spend your time building a package and giving it back to them, a user doesn't want to stick around for a ticket cycle. They open up a ticket and they wait, and they might have to answer some questions. a month later, they've probably given up on the application. So how do we make that more dynamic? And how do we enable end users to get more applications, not just necessarily the ones that they can give you immediately business justification around? And how do we automate more of the process that we're doing today? You know, everyone uses Adobe Reader in their environment, and Adobe has an update every month. And you've got to go out and repackage that, test it, and deploy it to your end users. That's a lot of wasted time that everyone's doing themselves over and over and over. So we've got this prototype calling App Factory. And the idea here is on the back end, you've got an appliance that sits in your data center somewhere. And this appliance listens to what we call feeds. Sort of like if you have an RSS reader. RSS reader can go out and check to see if there's any new news updates from specific websites and alert you if there are, and automatically download those updates. So taking that same concept, apply it to applications. What if you had a feed for Adobe Reader and you knew that Adobe had an update 10 minutes ago, and further, there was enough information in the feed that automatically could download that application from Adobe and convert it into a ThinApp package. And potentially, if you wanted to, make it available to the end user. So think about how much time is involved on your side to do that. It's none. So this is a nice value that you can start to automate a lot of the process behind packaging and delivery of applications. So these feeds, we'll have a much more detailed discussion in the future about what they look like, the format, et cetera. But in essence, these can be really simple. They can have just where you download the application, how you install it, with command line parameters, when it last updated, an icon. Beyond that, we're looking at how you pass in configuration information, serial numbers, list dependencies on components like .NET and Java, so that you can do this for a lot of the applications that you're using. So ThinApp Factory is, trying to say what can we do on autopilot that we're doing today through a lot of manual work. And I talked about all of these on this slide. Talking about security and compliance. One of the issues is if you want to give the users the apps that they want, then you need to give them admin rights, and then your manageability and your security and your compliance go out the window. As well, if you're looking at, say a stateless desktop model, that's hard to do without having all the apps users want in ThinApp package format already available to them. But who's going to spend the time to make all those apps? So let's jump into a demo of what that looks like. I know after the session, everyone's going to say, "Hey, when can I have this?" I want it, so I wanted to clarify that it's still a prototype. We don't have any ship dates yet, so. All right. So the ThinApp Factory is an appliance, and you log into it, using a web browser. And what we see here is the admin user interface for ThinApp Factory. We've got some feeds that we can subscribe to. Let me zoom in a little bit here. Feeds, ThinApps, and jobs that are currently running. You subscribe to new feeds. This is just basically that RSS-like code that's on some website somewhere. And you can control, how often it checks for updates and does the auto packaging. So right now, it's set up to do it once a day. We'll just click on sync to do that immediately. And it's instantaneous to get the list of the applications. So here we've got all the top applications on the internet that people might use. And you can see the last time that they updated. This is live updates from the internet. We know when Skype had an update. We know when Chrome had an update. Run that through a converter. Any changes, any new applications that got converted will be available to upgrade in either your ESD solution, or if you want, this appliance can actually have a user-facing front end that users can access those applications directly. So we're just moving the applitions from the admin staging area to the end-user facing portal. Now let's jump over and see what a potential end user might see. So here we are on this web page. User sees all the applications that have been converted and that we've approved for them to be able to use. And they just select the individual applications that they want. And the video is cutting out. Oh, there we go. There's a button here that says Get Applications. And through a browser plugin, we'll download and register those applications on the PC. Since the registration process is very quick, all we're doing really is a download, and we can have very quick deployments of all these applications. You can see on the start menu. They look to an end user like a normal application. Only difference they would know is the ThinApp loader bar in the bottom corner when they launch a particular application. Further, users could potentially subscribe to updates or update applications manually. So removing more of the things that they would have to go to an IT to do. The nice property about all this is, I'll let it run in the background. Nice property about this is these ThinApps, because they all run in user mode on lockdown desktops, you can isolate them from the rest of the desktop, let the user use the applications they want, potentially put additional security fences or parameters around the application so you're more comfortable giving it to the end user. And if we can get more people to create feeds for various applications, that work gets to be shared across lots of organizations versus everyone having to learn the knowledge and do the thing exactly for their specific apps that they're interested in. All right, so that was a quick demo of the App Factory. Okay, looks like I made it through my presentation a few minutes ahead of time, so we'll stop for questions, and reminder for everyone: don't forget to fill out your online surveys. Thanks.